Okay, I'm going to continue with the 68, 95, 99.7 rule with another example. For instance, the Council of Graduate Medical Education found that medical residents' mean number of hours worked in a week is 81.7 hours. The number of hours worked per week is normally distributed with the standard deviation of 6.9 hours. Okay, so according to the empirical rule, approximately 95% of students will have work times per week between which two values? Okay, so this is dealing with 95%. So if we add and subtract two standard deviations away from the mean on both sides, we would get the numbers 95% of the data will fall between 67.9 and 95.5. Okay. Now the next question, you want to stop the recording if you want to think about it here. What is about 99.7% of the students? So think about that. If you need to stop the recording, that's fine. Well, in this case, what you need to do is that you need to add and subtract three standard deviations away from the mean to get the two numbers, 61 and 102.4, where 99.7% of the data fall between those two numbers. So then the last question, stop the recording if you want to think about this, what approximate percentage of data will fall between 74.8 hours and 88.6 hours? Now, if you notice here closely with these numbers, these two numbers, if you compare it to the mean, is exactly one standard deviation away from the mean. And so what we can say here is that both of those numbers are one standard deviation from the mean. So 68% of the data fall within those 2 points. Okay. Now, like I mentioned in the previous recording, is that I would recommend drawing this up instead, where what you would do is that you would write down the mean here in the center, and then you would add 1, 2, and 3 standard deviations away from the mean on the right side, and then subtract 1, 2, and 3 standard deviations away from the mean on the left side, so that you have a good idea in terms of what, if I can, like I said in the last video, I can ask this question both two ways. I can say that what percentage of data fall between these two numbers here, okay, and that would be 68%, or I can ask 99.7% of all the data fall between which two numbers. So I can ask that in two different ways, okay. Now the next thing I'd like to cover is z-scores. Okay, now z-scores is suppose the variable x is normally distributed with the mean mu and a standard deviation sigma. Then the random variable z is normally distributed with a mean 0 and a standard deviation of 1. And then the z-score is calculated by the following. Now here's the formula for the z-score. Let me talk about this here, where the z is equal to x, which is some any given number, any data point, minus mu, and mu is the mean, divided by sigma, and sigma here is the standard deviation. Now when we calculate this, the z-score represents the number of standard deviations of value x is away from the mean. Okay, and we use, at least for this lesson we'll be covering, we'll use the z-score for three reasons. One is to determine the values that may be extreme. That's the first reason. Second reason is compare values from two different types of normal distributions. We'll cover that as well. And three, which we'll cover later, we're capable of using normal probabilities to calculate the probabilities of specific events with the normal distribution. So let's go to the first use, determine values that may be extreme. So for instance, mean incubation time of a fertilized chick egg is kept at a certain temperature is 21 days. Incubation times are normally distributed with a standard deviation of 1 day. What is the z-score of an incubation time of 20.5 days? Would that be considered extreme? And how about 25 days? Well, if we calculate these z-scores, so we take 20 and say the z-score for 20.5 days, we take 20.5 minus the mean divided by the standard deviation, we get negative 0.5. And if you look at this normal distribution down below, negative 0.5 is right here, and that's not too extreme. However, with the next example, how about the z-score for 25 days? If we take 25 minus the mean divided by 1, we would get 4. And that's way out over here, and that would be considered extreme. Now the last example here is the Council for Graduate Medical Education found that medical residents' mean number of hours worked in a week is 81.7. Now there have been rules recently that have changed how things need to go with how many hours that a medical resident can work, but we'll go with this. So the number of hours worked per week is normally distributed with the standard deviation of 6.9 hours. What is the z-score of a study time in a week of 84 hours? Would that be considered extreme? And how about 110 hours? So this is the end of the video, but I want you to think about it. Think about this, and then the next recording will go over the answers.